This is the last video of the first week in the first couple of days in DC Trig. This is 1.12, which is the 3 learning targets of finding the arc length of an angle, finding the angular speed and speed of something rotating around, and finding the area of a sector. Okay, so then let's go ahead and get this done. We're going to, first of all, take a look at an arc length. Now, an arc length is the length of the arc created when you have one side of an angle and the other side of an angle in a circle where this length is the radius, this length is also the radius, and this is my angle theta. So theta you get in radians, all right? Radians. It must be in radians. So if it's in degrees, you have to convert it. So then how do you figure out the length of this part of the circle? Now, part of it is that, remember that the circumference of a circle is equal to pi times 2 times the radius. So in order to figure out the length of a part, we're looking at the length of this, or the measure of this, in radians. Okay, that's how you find the measure of that arc. So it's a lot of it is related, all right? So this is the central angle in radians. Theta is equal to the measure of the central angle in radians, okay? So here's a couple examples like that. Find the measure of the arc. Now, this is 240 degrees, so this arc is what we're finding the measure of. And so the measure of that arc is equal to r times theta, but remember, theta is in radians. So 240 degrees has to be converted to radians. And in order to do that, we're going to multiply by pi over 180. So each one of these gets divided by 60. So 240 divided by 60 is 4, and 180 divided by 60 is 3. So this is equal to 4 times pi over 3, okay? And the radius of the circle is 4. So the measure of the arc is equal to 4, which is the radius, times 4 times 3.14 divided by 3. So what is that going to be? That's going to be 16. I'm going to use my calculator here. So 4 times 4 is 16 times 3.14 divided by 3. And that's equal to 16.7 roughly. And that's going to be 16.7 units. It doesn't tell us what it's in inches or what, but it's 16.7. Okay? All right. Now, what if we wanted to find the speed and the angular speed? So the angular speed is different than the speed. Remember, if something is spinning around like a windmill or something like that, it's going to be carving out an angle. So this thing's going to be moving around. Okay, so what the question is, how fast is the angle changing? That's the angular speed over time. And how fast is it moving? What is the length of the arc over time? Okay, so S, remember from the last example, is r times theta. Okay, so those two formulas are a big deal. Let's move on. So the question is, find the speed of an object. Okay, so the second hand of a clock is 10.2 centimeters long. This is r, right? Okay, so we want to find the speed of the tip of this second hand. Okay, so we want to find out how fast this thing is moving. Okay, So we want to find the speed. So remember that the speed of an object is equal to the distance it travels, all right, divided by time. So in this problem, okay, in this problem, it's going S is equal to R times theta. Now, what is theta? Well, theta is going to be 2 pi because theta is going to, we're going to figure out how fast this thing moves around in 1 hour, right? 60 minutes or whatever. So 60 minutes or 1 hour. So S is equal to 10.2 times 2 pi. Okay, now that's in 60 minutes. So 10.2 times 2 pi centimeters for 60 minutes. Okay, so we're going to find the speed in centimeters per minute. All right, so 10.2 times 2 times 3, we're going to substitute in 3.14 here to find a rough value. Okay, so we're going to do 10.2 times 3.14 times 2 equals, divided by 60 is 1.07. So 1.07. And that's going to be centimeters per minute. Okay? So every minute, this big hand moves 1.07 centimeters. Okay? That's the speed of that object. All right. So the next thing we need to do is find the angular speed. The blades of a wind turbine are 116 feet long. Okay. So this is 116 feet. And we can put that on the X and Y axis just to give us some point of reference. So it's 116 feet. All right, so this thing's spinning, right? This blade is spinning. All right. Now, the propeller rotates 15 revolutions per minute. So what that means is it goes around 15 times in 1 minute. Okay? So 15 times in 1 minute. Now we want to find the angular speed. Now, we got to figure out how many radians that is in 1 minute. Okay? So if it spins around 15 times, that's 15 times 2 pi radians. So theta is equal to 15 times 2 pi. Now that's 30 pi. And that is about, I'm going to guess it's about 100, but I'm going to put it into my calculator. So 30 times 3.14 is equal to 94.2. So 94.2 radians. All right? And that's per minute. So that's 94.2 radians per minute. Now, we've got to find the speed, right? So how many times, how fast is this blade going? Well, we have theta, which is 30 pi, and we have the radius, which is 116. So we're going to take 116, which is the radius there, times 30 pi, and that's every minute. So that thing is going to be moving, right? It's going to be going pretty fast every minute. So how fast is it going to go? We've got to use our calculator to figure that out. So we're going to do 30 times 3.14 times 116, which is 10,927.2. Now that's feet per minute. All right, that's how fast that thing is going. So that would be the linear speed of the fan blade moving around. Because it goes 15 times around in 1 minute. All right, so it carves out 30 pi units, radians. Okay? Oof, that's a lot of business going on there, but that's okay. Next thing we're going to do is find the area of a sector. Now, what is a sector? Remember, a sector is like a piece of a pie. So a sector is like a pie piece. And the formula for that is r squared times theta in radians divided by 2. 1/2 is the same as dividing by 2. All right, so we're going to do one example here. And we have a sprinkler that's 120 degrees here. Now, the first thing we got to do is change that to radians. 120 degrees times pi over 180, all right, which is, this is 3 and this is 2. So 2 times 3.14 times, divided by 3 is 2.09. So 2.09 equals theta in radians. Now, this is 70, and so it's going to be 70 squared, the area, 70 squared, times 2.09 divided by 2. All right, so times 70 squared, all right, and divided by 2, and the area of that is 5,128, okay, square feet. That's a lot of area there, but it's a golf course, so go figure. Okay, so applying the formula, 1/2 r squared times theta, or in other words, r squared times theta divided by 2. Okay, area of a sector, fun, exciting stuff. Okay, the blank speed of a particle is the ratio of the arc length to the time. That's the angular speed. And the area of a sector is r squared times theta in radians divided by 2. All right, that's 1.1 C and D, mostly 1.1 D. Okay, all right, watch the video, stop it if you need to, take your time, do your thing, get your assignment done.